again for day 2 now of the Advanced Users track. And we see that it's good to see a lot of familiar faces again, so I don't have a lot to discuss. I just do want to remind everybody that outside the room you've seen these cards with the QR code, and that is going to point to the website where you'll be able to find the copies of our presentations, example codes that we use, things like that. Maybe not today, maybe not tomorrow, but soon after the recovery from exactly. And soon after our recovery from NIWeek. So we've got one talk in this morning's session, and it's going to be Casey. And to tell us a little bit more about who's going to be talking to you, we have Alan Smith from National Instruments.
Hi. The mic works. Hi. Hi, my name is Alan Smith. I am in systems engineering at National Instruments. I also happen to be on the Actor Framework feature team. And a lot of my work is Actor Framework ecology. And I'm talking about myself to sort of give the background of how I came to know our next speaker. I got a phone call in late spring or early summer of 2012 asking, from this gentleman over here, asking about this newfangled Actor Framework thing, and do I think it works on a compact Rio? And I said, it's all G code? Sure, that'll work. Which, as you all know, is engineer speak for, here, hold my beer, this will be good. And so my summer project was actually getting a small Actor Framework project running on compact Rio. Yes, we found a showstopper bug, so I had to deliver up a workaround and a patch in 2012 SP1. And around the time we figured this out, Casey was pleased and said, hey, why don't you come on up to Wisconsin and help me get started on my project? And by the way, would you like to see my neutron gun? It's small and portable, it fits in a transportainer. So I did that, and that was a lot of fun. And Casey's been off and running ever since. Shortly thereafter, he stood for architect with an Actor Framework solution, which I got to see, and passed to be an architect. He's been working his systems now for 4 or 5 years. He is a frequent poster on the Actor Framework forums. He is a true friend to that community, but he's not a fanboy. He uses the framework extensively, but he will happily tell you about all of the pain points, especially on Rio targets. He's grounded through them, so you don't have to. When he applied to be champion 2 years ago, fairly recently, it was an honor and a privilege to talk Christian's ear off about why he should be a champion. And so with that in mind, I would like to introduce our first speaker of the day, Casey Linders.
Thanks everybody for coming. I guess there was some issues with some people getting in, so I'm glad you all made it through and stuck with it. So I work for Phoenix Nuclear Labs in Madison, Wisconsin. It's not in Phoenix. And I want to talk to you guys about LabVIEW classes and methods that you make and their settings. So who here uses object-oriented programming in LabVIEW? Right. Who here doesn't use object-oriented programming in LabVIEW? All right. Well then, so I hope that you all learned something, or maybe you're just going to nod in agreement the whole way through. But so who can remember when they were new to object-oriented programming? You probably all. Maybe it's only been a feature for a good chunk of time, but right, the Goop toolkit. Kale is not in here, but so when you're new, you're going to make some mistakes, and it's usually hindsight that, or a senior programmer that can see the problems. So when you're new, you probably have the one compelling reason is you think you want to use this thing called dynamic dispatch. Is that pretty much, like, that's the feature, right? But there's a whole bunch of other stuff that comes along with LabVIEW classes, and I'm going to talk about a bunch of those features. And there's a bunch of things that if you don't know how to set them up, they don't work quite as you would expect. The example I put here is the feedback node that mysteriously doesn't work when you spin up 3 things that all use the same VI with the wrong settings. And we'll talk about what those settings might be in a few slides from here. So you should be here. Obviously, everybody except for 2, I think, are currently using object-oriented programming, and you're using it most likely because you want to be able to build reusable pieces of code. You want to extend behavior. You want to force implementation of behavior. And I want to help you avoid some pitfalls, and we're going to do that basically in a few main areas. And the default settings are not always the right settings for where you're going to use your methods. So we're going to learn about what the defaults are, when the defaults work, and when they don't. So the main thing I'm going to focus on is a bunch of settings that you can find in your class properties. And I'll show you how to find, well, I'll tell you how to find the class properties. And I'm going to focus on 3 areas: access scope, dynamic versus static dispatch, and then some of their features. And then this reentrancy is not object-oriented limited. It's any VIs that you make in LabVIEW. But you need to be aware of these, and I think they become a little more important when you're doing object-oriented programming, and like for me, the actor-based stuff where I have multiple instances of things. So to get to your class properties, you can simply right-click on the class. I'll give you a quick tip right off the bat. If you get a project with lots of classes in it, if you go to the File view in the Project Explorer and right-click, it populates this properties window almost instantly. If you right-click in the Project view, Project Explorer view with the virtual folders, etc., it can be painful, and somebody at NI can explain the difference between the two. So we're going to look at 3 different categories of settings in the properties. So we've got your item settings, your friends, and your inheritance settings. So that's this column here is your category, and these 3 windows are just highlighting different categories, and they have slightly different options. So let's start off with access scope. And you make your first class, you make your first method, and it is a public method. And so come on in, we're open. You can drop that method anywhere in your project, and it will, well, as long as you wire the required conpain terminals, it will not be broken. That's the default. And so if you create a new VI from static dispatch or dynamic dispatch, you're going to get a public method. And that might be a problem. So who here already knows access scope? Who's like an expert at access scope? Okay, well, so I'll show you a few things here. I got a couple different views of access scope and a little UML to sort of describe it. So there's 4 different levels of access scope. The flyout menu has them listed in the opposite order as the properties menu, and for consistency, maybe they should be the same order, but that's a nitpick. So private methods can only be called from the class itself. So you have to be in a method of the class to call a private method of that class. Protected methods can be called by descendants of the class. So if you have a parent-child relationship where the child inherits from the parent, and I'm not going to cover inheritance because I think since everybody except 2 people raise their hands, we can kind of breeze past that. So the child can call the parent method. The parent can probably wouldn't know about the child method. It could be a dynamic dispatch, but we'll go into that. Community, who here uses community scope? Okay, so I have a use case for community scope. And when we talk, so what are your use cases for community scope? Unit testing, X controls. Saw a couple other hands, but so maybe I will give you another reason to use community scope today, and then public, which we already talked about. So community, you need to be a friend of the class in order to call a method. And then public, that's really the API, or the application program interface for the class, and that's how you are going to interact with the class. So here's another view of these. So in a class UML diagram, we've got different minus for private, hashtag for protected, tilde for community, a plus for public. And you can, if these are each box here is a different class, and this this folder here is a package or a set of friends. If you have a private method from class A, so these will all refer to class A, a method in class A. If it's private, only class A itself can call it. If it's protected, class A and B can use it. In this instance, classes C and D, I'm saying, are friends of class A, so they can call the method. And here, classes E and F are not really related to class A and through inheritance or community friendship, so they can only access the public interface of the class. Does this make sense to everybody? So let me give you my use case for community. So using Actor Framework, I want to make it so that I have methods that you can only call through the message. So in Actor Framework, you create messages that are classes themselves. And the message class has a do.vi, and that do usually calls some method. And I will make the method be a community scope, and I will make the message class a friend of the actor, and then you can only call that in the message class. You can't call it from anywhere else. You can call it from inside of the class itself, too.
So that is a suggested best practice if you want the message itself private to the actor. There's a little bit of overhead, so if you want to use Youre as a good thing to do.
Did people hear that? Okay, so Alan said that's a recommended best practice if you want the message to be private to the actor. Yes, a message the actor sends itself. You can make it so that other things can send the message. So it's not actually required for only. Okay. So let's move on. Oh, question?
How are you saying the scopes of the message can call protected methods in the actor, or is it that the actor is maybe calling something?
So I'm setting the the method in the actor class, so in like if the actor is class A and the message is class C, I have a execute something, right, in class A, and that's part of the interface I want to interact with. And I change the access scope of that execute something to be community, and I make the message that calls the execute something be a friend.
So if you had a hierarchy of messages, would it be the child message that actually erases that after it set the community scope, and then maybe its parent wouldn't be a friend of the class if it was a generic parent of a specific implementation?
I'm thinking about that. So the question is, if you have a hierarchy of messages where it's the child message that you're actually calling, would and the parent message doesn't get called, would the parent messages act? I lost you at about there. Like, okay, I got it. I understand what you're saying. Parent and child message classes, that's pretty common for zero coupling, and
So only the child message would be a friend of the actor, not the parent.
I think it would have to be the parent. Or no, wait, the child, yeah, because the parent doesn't have a do. That is correct, I think. So the structure of the messaging that John is talking about, the parent class contains the data, but doesn't contain the do method. And show of hands, who here has used Actor Framework? Oh, that's pretty good. So who here uses zero coupling? Who here read my post on two-way zero coupling? Who here has tried that? Okay. All right. So a few months ago. I would have presented on that, except I think it's too technical. So the message class, if you want to do zero coupling, the parent contains the data and the child contains the do, and the do contains the method call that's in the actor. So you'd have to make the child class a friend of the actor. So in that case, like if class C was the parent class and class D was the child class, you could actually have class E be the parent class here where it's not in the package, and you could have class D be a friend of class A. Let's move on. So I want to shift gears here. I presume that everybody has used dynamic dispatch that's using object-oriented programming. So this should be kind of a no-brainer. You already know how to make a new VI for dynamic dispatch. You can use the shortcut from the template, or you can wire up the con pane and right-click on the connector and make it a dynamic dispatch input required, and then you can choose on the output whether it's dynamic or static. So you use dynamic dispatch generally when you want to change what happens based on the class that's on the wire. So, and usually you do that to extend or to implement some behavior. And there's a couple options here. Requiring descendant classes to override the dynamic dispatch VI and require overrides to call the parent method node. Let's work through a few of these and talk a little bit about what it means to be a dynamic dispatch method. And the first thing is you have to fulfill your promises. So if you are a class that implements a parent class's interface, you need to fulfill that promise. You can't leave things unimplemented. you don't necessarily have to extend things, but you do have to at least fill in for your parent. This is a key thing to remember. You can put functionality in the parent class, you can leave it out. There's a whole bunch of different ways to do things, but you do have to provide the functionality. So usually what I'll do is, if I want to enforce, I will click the must override, require descendant classes to override this VI. And so here's an example where in the UML here, class A, so on the left example here, we've got class A, class B inherits from class A. Class A has method A, it's a public method that we've said you must override. Before you create class B, there's no problem, everything, no broken run arrow. You create class B, no broken run arrow. You change inheritance of class B to inherit from class A, broken run arrow. This is good for anybody that's working with other developers. All right? So you don't have to do this if you're like a one-man band and you know what you're doing and I'm just going to be okay with it. But as soon as there exists a possibility that you might be successful and maybe have to hire another person, God forbid, having that checkbox checked can be really helpful, because then the junior developer or your future self that doesn't remember, right? Because you've got like this, our brains are shrinking. Question?
So some time ago I started to use it, and after that I decided I should not do it. So why? Because if you have one child class, there is no problem here. If you have several children, you have problem. Why? Because the very background structure of work is test every piece of code. I implement this method in one child, and everything is still broken because I didn't implement in other children. So as a result, I cannot test until I do implementation, maybe fake implementation, maybe some kind of not really code, but I must do something in all children. Otherwise, the whole program cannot be tested. And when I implemented, say, in 10 children, I already forget what I did at the beginning, and I have more problems with the code part. As a result, I always put, when I want this outside method, must override, I put error launcher in this outside method instead of selected must be overridden.
So I think the takeaway that I have there is, so the point was, if I create 10 children of class A, I have to implement method A in all 10 children before the run arrow is not broken. And I want to test sooner than that. Like, I want to have just child 1 implemented, and I want to test child 1. So I would say there's a few things that I would suggest. One is scope your work. Why did you create all 10 children at once? I'm sure you have a valid reason.
They were created. I add one of the here.
So yeah. Okay. So everything's working. You add another class, another message, another method. Okay. Well, you can check it item by item.
So I have to remove all children from the process.
So if you add another method to the class A, right? So you're going to add method B, and you check must override. Well, do you have to override it in every class? Then Sorry, override it in every class. It's broken. Compiler is helping you. This is help. I mean, that's my, so, I mean, I understand. So if you want to test just class B with methods A and B, create a new project, add class B to the project. It'll pull class A in and write your
There
test.
is a simple way. Put error launcher in your app.
But that's, yeah, that's a runtime error then.
Yes, but you get it.
Well, you want to catch your errors early. I'd rather have a compile time error. Well,
First run, you
I guess,
this early is too late.
yeah. Yeah.
Fine. I'm loud. The simple solution would be just go ahead and make the children make their methods. By default, it should have the must call parent. It should call the parent method by default. So therefore, it'll just follow whatever method B was in class A. You're done.
So what Tim's point was is you can create a new VI for override in every class, all 10. Of course, if you have 1,000, it's a whole other discussion, right? But and that's scripting land. And then the default implementation of the override is just a call to the parent. So you could do that, and you wouldn't be broken as soon as you created all of the default VI for overrides.
So then haven't you just removed what it was you're trying to save yourself from? Because you remember to do something
Yeah,
valuable.
well, you must have it. I think it's in the class. Okay, so the point was that the irritation is that it's not the children that are broken, it's the entire hierarchy that's broken. So then I guess you'd have to have an application that knows ahead of time what classes could be on that wire and what happens when you load a class by default value and cast it to class A, but it's actually class B, and class B doesn't implement the method, like a plugin architecture that would, or don't have class B or whatever, class C, D, E, or whatever in that one project because it's out of scope for that project.
Not to delay this any longer, but isn't it also a question of when this happens? At the very beginning of the project, you check this versus a year later?
Yeah, so the point was, is it also worth mentioning that when you check this checkbox can be important at the beginning when you create class A and method A, and then every time you create a child, you don't have a problem, but I mean, software changes, right? You don't want to change the interface to your parent class unless you really have to, but who here hasn't added a method to their parent class in the future because they realized they need it? I mean, I think everybody has done that. Is there anybody that hasn't done it? Yeah, okay. So, yeah, yes. So just to finish out the example, if you have a method that is must override, when you say new VI for override, it'll show up on the top of the list with the asterisk in front of it. And then if you create that method, so on the pair of write classes there, class B implements method A, and now the run arrow is restored to the unbroken state. At some future point, people can talk to me on their own about maybe if we want to continue on the merits and pitfalls of that. Here's the next little trick with, oh, go ahead.
I just had a quick comment about this, that you can actually kick the implementation down the line to children.
That's my next slide. So you can defer implementation to grandchildren or great-grandchildren. There's a little checkbox here This is in the inheritance tab. Transfer all must override requirements to descendant classes. So in this example, class B transfers its must override, and then when you create class C and say that it inherits from class B, you have to implement method A, and in that manner it skips a generation. You could also transfer the must override in class C to push it down further. I have a use case that I've mentioned to Alan and Stephen that I'd like this to be item by item selectable, because there's some things that I'd like class B to have to do and then there's some things that I want class B to skip and have class C have to do. And so I think that in the item settings this should be all right, capturing that. So because I don't like the idea of transferring all of the must override to your children. There might be one thing I really want you to must override, but we're going to have some, the tech preview this morning. Everybody got to see, and we're going to we have a chance to inject our voice into the software development process. Not yet. All right. So next, let's talk about the must call parent option. So what I do when I make these presentations is I just take the essence of the statement and I do a Google search, and it's often I find it humorous what I find, but so when got to get some screenshots here. The slides will be available at the little QR code upload place later. So you will put this option, the must call parent, when you want to extend behavior. So if you create method A in class B and it must call parent, and you were to, so this is the call parent node for this protected method. If you were to delete this sub BI, this parent call, this BI will be broken. And you can't have it in a case structure either, because it must be called no matter what. Yes. And so a nuance here that I've run into is if you are doing something that, this is something I'd also like added, here's another note to take, so my use case here is configuration. So I had a short configuration hierarchy where they kind of added a few extra bits as you went. And I always wanted you to do the configuration of your parent in addition to your child configuration values. But before I did everything, I did some checking. And you had to do the checking before you did everything else, and the checking was in class A. So must call parent before you do anything else. It's only enforced by the developer. So there's a thing there. Order can be important in must call parent, so don't get burned by doing things out of order, because it is data flow programming still. And has anybody been burned on this? All right, you got more than a half a dozen people.
Sorry, if you are going to add a must call first, you also add a must be a last call, depending on what.
So, right. So the comment was, if you're going to add a must call first, can you add a must call last option? These are ways that the editor would help us, right? So the broken run arrow but you know, a compile time error versus a runtime error. Putting it in the wrong spot gives you a runtime error, and you'll find it sooner or later. But it would have been, you know, you can annotate your code and say, do this first, do this first. But once you're like down in like class C, if B overrode it and A had the note for like you got to do it first, and you don't go all the way back up to A, you know, it's fallible. Okay, so Alan says there might be something you can do with the VI analyzer test. Brandon has a... So inherit comments from your, if you're a child, would be an interesting feature, is what Brandon says.
So your mom's voice follows you around your entire life?
It's haunting you. Right, right.
I think I prefer to just not check it and implement it and have it. And what I'm trying to do is make sure it's always adequate.
Yeah, so the point was, rather than make it a parent method, put it in a separate method that happens before, so that you do that unequivocally, and then you do the next thing, and that would control or remove the need for order. I think that's a really good idea too. Probably it's poor software design, and you know, we all kind of run into things where we go, oh, I really should have done that check like before doing my config, not as part of my config, and that would be a nice little refactor that would remove any potential for, you know, putting it in the wrong spot. Any more points on this? Okay, so next I want to shift gears to our last topic here, which is reentrancy. And so sometimes you need one and only one. My example here is the alphabet. A counter example would be a book might need multiple instances of the letters in the alphabet, but the alphabet itself only needs one instance of each letter. And sometimes you need one for everybody. So you don't want to share all the time. So who here has gotten burned on reentrancy? Who here doesn't know if they've been burned on reentrancy? It's waiting. Who here uses reentrancy settings on every method they make? No, is deliberate about what the reentrancy settings are on each method in a class. Okay, so my goal is, after you leave here, you'll all be deliberate about every method you make. This is another, so all of these settings that we've been going over today, in my opinion, should be part of method creation. Okay? I told Omid this directly, so.
You know, I completely agree with you. It's extremely important, specifically for performance. But when you create a method, it's first debugging. It's easy to do this non-reactive method.
That is
After
true.
that, change to share it or preallocate.
After you're done, like the class hierarchy thing, you can show also the method hierarchy, and you can choose either to choose working on override and working on that or not. So that in the whole scheme of things, that you can do the settings, it's probably better rather than trying to do it at the middle level and not really doing for all the other settings. So it should work in the plot, not like a constant window.
Okay. So the point in the front here was that sometimes more context is needed than just the individual method, and it'd be nice to see how that method lives in the context of the other classes in its hierarchy and other classes in the project. And I can see that, yeah. The other point was that sometimes, well, he agrees, but when you create the method, having it non-reentrant and public makes it easy to debug and test like quickly early on, and then later you could change the settings. And my complaint is, I understand there's tension between like lowering the bar to doing things, because you don't want a developer who's new to object-oriented programming to create a method and like have a the blank stare that Becky talked about yesterday, like the new VI syndrome, like, oh, now what? You want them to give them something quickly that they can get working with, and if they have to be knowledgeable in all the settings, it's an additional hurdle. But if you don't make all the settings correct, then you learn other lessons, which is your code doesn't work the way you wanted it to, and it's hard to fix it.
So what I've been wanting for about 10 years is a nice context-sensitive window that you can click on, and you have all this Control-I stuff right there. You can do it very fast without having to wait for that user to pop up.
So the point here was a context-sensitive window that would have all of the settings maybe on the right pane. I'm just guessing that maybe that's where it would be, where you could make all these settings. So, so we have 3 options for reentrancy. The default is non-reentrant, and that is the alphabet example. There's one and only one version of that method in your program, period. It's a singleton. There is one of it. And I'm going to show some diagrams and do a little deeper dive on each one of these. Shared clone reentrant means there's more than one, but they're created when needed and then stored in a pool of clones that can be accessed. And then there's preallocated clone that at start of execution, a copy for each one is created. So let's we'll do some words, and then I'll do a little sequence diagram. So non-reentrant, I think I covered pretty well already, except I need to give you the pitfalls. Because you have one and only one copy, there are things you cannot have if you intend to use it across multiple, multiple things are going to hit that one method in your program. So you don't want to, unless you're a functional global, LabVIEW 2 style functional global, action engine, you don't want to have stored data because it will be shared data. So a feedback node is a huge no-no, unless you understand that it's shared by everything. If you need distinct copies, my example was a PID method where you're doing PID and you're all good on one controller, and then you have 2 controllers and they need to operate on their own data, and the input is different, and now you get like this averaging of the inputs, and your error is somewhere in between and nothing works. So feedback nodes, sub-VIs with while loops with shift registers that execute once, that sort of thing. You need to be very careful. So one thing you can do on these is you can have a unique copy of the private data and act on that and then store it back. These are good. I use them in my, when I'm starting out my program and I'm going through configuration. If you have a single resource that you need to protect, you might want to put it in a non-reentrant method. So like file I/O, like accessing a file reference, if you've got a fast computer and you spin up a whole bunch of things that hit that same reference at once, it may just not read it. So you need to that's a good use case for this. And here's here's kind of what it looks like. So this is a sequence diagram. Time is going vertically, and we've got two objects here, and they both get this message A, which causes method A to execute, or execute A to occur. And while the first object is executing A, the second object is blocked and waiting for that resource. And then when it becomes unblocked, it will execute A, so on and so forth. And while the second object is executing, the first object doesn't have access to it. Any questions on this? Everybody agree with what I'm saying so far? It seems right?
Yeah. This seems to be true of VIs regardless of
Yes,
whether or not you're doing
Chris,
roll up.
yes, that is correct. Good point. So these reentrancy settings are ubiquitous across LabVIEW, not limited to methods in classes. So even if you're not an OOP programmer and you have a method, you can make deliberate setting choices that will affect how it's run. So shared clone. So copy is created when it's needed, and then it can be shared if there's something already using all of the copies and you need to execute that method. The system will create another copy and add it, and then use it there locally, and then when it's done, it gets returned to the pool of clones. Can be used on both dynamic and static dispatch methods. I point this out because the next example, the preallocated clone, you can't use on dynamic dispatch. And I'll tell you why, but this can be used on either. So this is going to be, if you're using dynamic dispatch methods and you're using multiple copies, this is going to be your setting. Again, no stored data that you want to use in several places. So you can get data, you can scale data, you can range check. These are things that I do. And you're providing all the input and you're getting an output, and there's nothing held within the method. So it's totally fair game to hold all of the data in the class, private data, because then you have an individual instance of each class which can provide all the inputs and receive all the outputs. But you don't want to get in a case, again, where you have a feedback node or the while loop shift register action engine. There is, so jitter can be an issue when the new clones are created. So here's the diagram. I added a create clone here. So the first object gets message A, it creates the clone, then it executes. Then the second object, then the clone 1 is free to be used, and the second object receives message A and says, oh, I'm going to grab clone 1 and I'm going to execute. A little later, there's a case where the first object is using clone 1 and the second object needs to have an instance. So it will create another clone and then execute. And then from there on out, clone 1 or 2 are available. And you don't know which one is going to get used. If you're going to debug these, you can set breakpoints, so and it can open the actual instance of the clone that gets called, so you can probe on them. But you can't debug these by opening the VI and then running the program, because it's going to create a new clone. Questions about this? John? Does the pool ever get released? So that's an NI R&D question, I think. I think they go away at the end of the program is probably the answer. So, like when the program closes, when execution stops, they're probably
Yeah, your top level.
yeah. So yeah. So
Yes.
One bit of tidbit of information on clones. If you open up the root VI and you go to Browse Relationships, you can find the clones that you've launched without the breakpoint.
Okay.
And that was a tip that I learned.
That's an
like
excellent
in the
tip.
last year.
I didn't know
awesome.
that.
Is go to Browse Relationships.
Browse relationships on the VI that calls the
No, the root VI.
the root VI. Okay, so the VI itself, so execute A here is calling method A. I go to method A in my project explorer.
No. In the VI itself, go to View, Browse. I can't remember the exact thing, but it's in View, Browse Relationships.
Okay.
And to say Open Reentrant VIs, and it'll give you your 10 clones that are launched, and then you can go pick each one, and then put probes on each one.
Okay. Does it work in real time?
I think so.
From the development environment, I should say.
It should.
I'm just going the next step and saying, is it also working in real time?
I just learned that last weekend. That's a good
One small question. When we work with debugging of flows, we often open many components and they don't disappear. You know some methods to close all of them?
So a method to close all of the front panels of your clones. And how did you open them to begin with? The probe, like a breakpoint? Right.
In master VI or put them open component code. It's very common in debugging.
Sure.
But after that I have 60 or 100
Chris had-
components to close when
So this is hilarious. I just got through facing this problem 3 days ago. The question becomes, how do you find all instances or all clones of a VI in memory so you can close them all down, right? In effect. Well, the answer is you can use VI Server. There's a hack, I hate to say it, there's a hack VI that you download on Lava, and it will tell you the number that you post-append to the name of the VI so that you get its full clone name. Then you call OpenVI reference on it to show its front panel. Then you can kill it off. I haven't yet been able to find a way to call abort VI on a clone without LabVIEW throwing an error. That's actually one of the questions I'm hoping to get solved here. But that's how you go about doing it. And then this gentleman pointed out, if you do get an instance of a clone, you can go View, Browse Relationships, and you'll be able to get access to all of your clones
yeah,
from there.
you can open certain.
Absolutely.
And do whatever.
Right, but I think
know.
you had a separate question, right? Which is if you have 20 of these things in memory, how do you close them all? If you do Control-Shift-W, you go to the All Windows browser, and they'll be sorted basically by name. So you'll see them all in alphabetical order. You select them all. There's a close button, and
Wait, all the clones will show up in that window?
anything that's open. He's talking about having them open. He's looking at 20 different front panels
Oh, I
to
see.
do this, and now he wants to go back and close them all without finding
Oh, I
But
20 windows.
it doesn't
in
stop
X.
them from running, though.
That doesn't stop before.
Oh, but if he has them in memory, he just wants to close. I mean, I think he was talking about just once you're debugging and you have 20 of these things open, how do you quickly not have to go hit the X 20 times? And I would say just use the Control-Shift-W for the all windows.
All right. We have like 5 more minutes, so I want to get through the last couple slides here. Preallocated clone. There's a copy created for every instance. And this is the default setting for if you create a data accessor, like a new VI for data access. This, you can't use this with dynamic dispatch because you don't know which type you're going to need, what's going to be on the wire in every instance. So you can only use this with static dispatch methods. And so the use case here is you've got a method that's used in multiple places, they can contain unique stored data. So this is where your PID loop can live. So some of the drawbacks here, I would say well, I already mentioned the static dispatch. All the clones need to be created at start of execution. So there's a little slower startup. I don't have benchmarks on any of this. It's just, leave that to the guys that do the benchmarking. And higher memory usage. My benchmark is what percentage of CPU am I using on my compact Rio? And when it's, like 10%, I'm like, I don't really care. And if it stays there for a day and the memory doesn't go up, then it's okay. So here's the sequence diagram. So the first and second objects each create a clone at the start, and then all throughout execution, they use their own clone forever and ever. Amen. So so a little recap here. We covered a few settings that I think are really integral to writing good object-oriented code. Access scope, controlling that makes it so you don't put, you or other developers don't call methods where they shouldn't be called. So that's really about controlling where things can be run and creating broken run arrows if you put it in the wrong place. Dynamic dispatch with a focus on the override versus extension. And then the reentrancy settings that aren't limited to methods and classes, but are very useful to know when you're creating things. And again, the default is non-reentrant and public. So everybody should think about what that use case is, and then realize that only when you create methods that meet it can be called by anyone, and there's only one copy of it, then you don't have to change any settings. So I would venture to guess that's like, I don't know, 1 in 20 methods. Maybe 1 in 100, maybe 1 in 1,000. It's not a lot. So you want to, hopefully now you're a little bit more expert in what these settings are, and the way you get to them, go to the file view in the Project Explorer and right-click on the class and go to Properties. And then you can browse the different categories. That's it for me. So. Questions? There's lunch after this, and I don't think the room is scheduled for anything. We have our lunch with Jeff. Some of us do. So, so yeah, questions.